Today we will be studying zero order reaction and its half-life. So what is a zero order reaction? A reaction is said to be a zero order reaction if its rate is independent of the concentration of the reactants. So let's suppose we have an equation A gives us P, where A is our reactant and P is our product. So its rate will be directly proportional to concentration of A raised to the power 0. And to remove the proportionality sign, we will write a constant K, which is rate constant. And all of us know that anything raised to the power 0 is equal to 1. Therefore, our rate will be equal to K. So our rate is equal to K, where K is rate constant. So also we know that rate is written as decrease in the rate of concentration of reactant with respect to time. So we can write minus dA by dt equal to K. This where this negative sign represents the decrease in concentration of reactants, while the remaining, this represent the instantaneous rate of reaction. All right. Now, if we take this part only, minus dA by dt equal to K, and I transfer the time term to the left hand side, I'll get minus dA equal to K dt. On multiplying both sides with negative, or I can say multiplying both the sides with minus 1, this negative sign will become positive and we'll get a negative sign on the left hand side, right hand side. Now on integrating both the sides, here minus K is a constant, so we'll keep this outside and integration of dt. And there is a rule for integration, that is integration of dx is equal to 1. So here integration, so not 1, it's x. Integration of dA is equal to concentration of A is equal to minus K T plus constant of integration. Alright, so this, let's suppose this is our first equation. Now at time t equal to 0, or we can say at the starting point of reaction, our concentration of reactant was equal to concentration of A naught. Therefore our first equation will become A naught is equal to minus K into T was 0 plus I. Therefore I is equal to A naught. This is same. So putting value of I into equation 1, will get a new equation, that is concentration of A equal to minus KT plus A naught. This equation is our integrated equation for zero order. And if we have to plot a graph between concentration of our reactant with respect to time, we'll get a graph like this, and the intercept is equal to A naught and our slope will be equal to minus K. So this is it. Now we'll take a next page. So our equation was this, minus KT plus A naught. Alright, and I can also rewrite this equation as concentration of A naught minus kt. And if I have to write the value of k, I can write it like this. K is equal to concentration of A naught minus A divided by T. This is rate constant expression for zero order reaction. And if I have to write down the equation for time, the equation will be A naught minus A divided by K. Alright. So let's suppose this is our fourth equation, this is our fifth equation. And we know that the rate of zero order reaction is directly proportional to zeroth power of concentration. So if we have to plot a graph between rate and concentration of reactant, we'll get a straight line graph which is parallel to our concentration of reactant excess. So that's it. Now half-life period. Half-life period or half-life time is defined as the time taken for the concentration of reactant to decrease to half of its initial value. So what I am saying is half-life time is that time at which concentration of our reactants become half of its initial value. So at T equal to T half, our concentration of reactant, that is concentration of A, is equal to initial concentration divided by 2. Now if we put these values in equation 5th, what we will get? We will get T half is equal to A naught minus A naught divided by 2 divided by K. So in the final equation, we'll get this. This is our half-life time of a zero order reaction. So what we can say, the half-life time of a zero order reaction is directly proportional to our initial concentration of the reactant. And if we have to show this by a graph between T half and our concentration of reactant, we'll get a graph like this with the slope is equal to 1 by 2k. So this is our half-life period of zero order reaction.